Hello, I wanted to introduce you and welcome you to our course, introduce myself, why I find geology so interesting, and also get you started on thinking about three main kinds of diagrams used in geology. I'm Dr. Andrea Baer. Please call me Andrea. I'm originally from Michigan and went to Michigan State to earn my Bachelor of Science in Geology. I then moved to Nebraska to work on a PhD and lived there for a while. I have a broad background in many areas of geology, but I specialized in sediments and sedimentary geology and vertebrate paleontology. I studied ancient river deposits of the Great Plains and fossils in those deposits, focusing on fossil pikas like this cute relative from today. Pikas are the size of guinea pigs, but are the closest living relatives to rabbits and hares, and were really common in the past. As I was finishing my PhD research, I had an opportunity to live and work in China for a few months, and I taught at Northwest University in Xi'an, China. If you've ever heard of the Terracotta Army buried with an ancient emperor, that's near Xi'an. When I finished my PhD, I then worked for several years as a research fellow in science education at the University of Colorado in Boulder in the geology program there, where I did research on how people learn geology. I still work some on related research, but I promise I'm not using you as guinea pigs. One recent project I've been working on is to review work by the authors of your textbook and collaborate with them. I also work on a project called SAGE-2YC, which stands for Supporting and Advancing Geoscience Education at Two-Year Colleges, in which I get to work with community college faculty in STEM, or science, technology, engineering, and math, fields all across the country. After the project I worked for at Colorado ended, I taught for 2 years at Central Michigan before I came to Delta in 2013. Most students in this course are interested in aspects of geology but are not planning to be geologists, and this class is for all of you. Most of what we'll do in this course is practice skills that employers want and value in college graduates. We'll just do it through geology content. The information here is from a 2013 survey of thousands of employers, and more recent surveys have very similar results. Employers want critical thinkers who can communicate and solve problems, no matter what those students' majors were in college. This information is from that same survey and highlights the skills and abilities that employers want colleges to do more of to help future employees be more successful. Please notice that critical thinking, analytical thinking, problem solving, communication, applying knowledge and skills to real-world settings, and similar knowledge, skills, attributes are at the top of this list. I try to keep up with surveys like this and set up my courses to emphasize these desirable skills. I've been in school for or teaching geology for most of my life now, and I still think it's the most interesting and exciting field. For me, geology is a form of time travel. The past is recorded in Earth's rocks and landscapes, and if you know how to interpret those rocks and landscapes, you can visualize the past. You may know some about two time periods in Michigan's geologic past. The last ice age, about 2 million to about 15,000 years ago, when we had huge glaciers over part or all of Michigan, and then much, much earlier, when Petoskey stone corals were alive and living in a shallow ocean about 450 million years ago. One cool thing about Michigan geology is there's lots of places you can see evidence of both of those time periods, like gravel pits with Petoskey stones. Here's another. A ledge of limestone from the time of Petoskey stones, and it got grooved and scratched on the top of it from glaciers traveling over it. With knowledge of geology and paleontology, we can construct what Michigan most likely looked like in the past, such as this painting in a museum of big mastodons, musk oxen, and there's a deer somewhere hiding in there, roaming over the plains and forests at the edge of the giant glacier that's in the background and to the left. And here's a reconstruction of ocean life from the time of the Petoskey stone coral, about 450 million years ago, made possible by the science of geology and paleontology. So understanding the amazing places in Michigan, like the many sand dunes we have along the Great Lakes coast, is part of why I like geology. as is understanding and appreciating fossils like Petoskey stones. Geology also includes understanding our relationship with our environment. Maybe you recognize a problem with the quality of the water from Flint in these sets of samples. Understanding water resources and how to use them safely are also geologic issues. Geology impacts many aspects of our lives, but we often don't recognize how much it connects. In this course, we're going to use a lot of diagrams and visualizations, and I want to introduce you to some of the main types. Today we're mostly going to focus on maps, cross-sections, and then diagrams that show 3 dimensions, like block diagrams. Sometimes these are also called perspective views if it's in a photograph. So we're going to use a common feature to illustrate these different types of diagrams. What we're looking at here is Meteor Crater, also called Barringer Crater in New Mexico. This image is a photograph from an airplane that shows a perspective view of the crater. It's not taken from directly above or directly from the side. Some useful aspects of a perspective view is that it gives you a sense of the depth of the crater, and it shows objects that give you some sense of scale, such as you can sort of see the paved road in black and parking lot, and there's a few cars there looking very, very small. This photograph is from directly above the crater, so it's called a map or top view. A map view gives an accurate representation of the size and the shape of the crater, but its depth and steepness are not represented. Sort of like you're flying above in an airplane or a bird, if you can imagine yourself as a bird. The third diagram we have of Meteor Crater, it's not a photograph. It's very brightly colored, and it's got different layers represented, and it looks like something you could actually draw with colored pencils if you were extremely neat. This is a cross-section diagram. It's illustrating an interpretation of what a slice into the earth at the crater would look like if we could see it from a side. So it's like a slice cut into a layer cake, and then you see the layers when you serve the cake. Cross-sections are interpretations based on data. Here the data used to study rock types of the current surface of the crater, and also a borehole drilled into the middle of the crater. Included also in reconstructing this setting is a lot of knowledge from other studies on crater formation. Another type of diagram that geologists use that you'll see in your textbook from time to time is something called a block diagram or a 3-dimensional diagram. It shows both a cross-section or even multiple cross-section views and gives you perspective of the landscape. Here our example is the rock layers at the Grand Canyon. One really neat thing about this diagram is it shows volcanoes erupting near the rim of the canyon and lava flows going way down into the canyon. This is not something you can observe happening today. There aren't any active volcanoes near the Grand Canyon, but it did happen in the past few million years, and this diagram is trying to illustrate that. Okay, so now I've got some examples that you'll try to figure out the type of diagram each represents. So in this case, I've got cupcakes for you. I apologize for teasing you with cupcakes. Thinking of layer cakes always makes me think of cupcakes, and it's pretty good actually at illustrating this sort of thing. So the question I have for you here is, which of these letters with photographs is showing a cross-section view? Pause the video while you make your choice. Play it again to see the answer. If you chose C as the cross-section view, you've got it, you're on the right track. Hopefully you would also say that B is a map view, or right from above, and then A would be a perspective view of these cupcakes. So let's look at something geological rather than cupcakes, although maybe some of us would rather look at cupcakes so far. This is a volcano in Japan called Sakurajima, and I've got 3 images for you. Which image, A, B, or C, shows a map view? Pause the video while you make your choice and play it again to see the answer. If you chose A, you're right. B is similar to the cross-section diagram, but it's a photo right from the side, so this is usually called a profile or a side view, but very similar. C would be the perspective view then. One more example here. These are all images or diagrams of the Grand Canyon. So take a look. Which one do you think, which letter shows a perspective view? Pause the video while you make your choice and play it again to see the answer. C is the perspective view here, and B would be a cross-section. Remember, cross-sections aren't photographs, but are interpretive diagrams, and here A is the map view. A might look a little weird to you, like it does to me, as it is taken from a satellite in orbit around Earth, and the lighting is not what our brains prefer. The canyon and river might look like it's higher up in elevation than the surrounding landscape, but really it's the canyon digging into the ground that we can see more clearly in the perspective view in image C. Weird but true, our eyes can play tricks on us. Actually, it's our brain playing tricks on us. So it's just something to keep in mind if you're looking at these kind of images. And that's it for me here in this mini lecture. See you soon.